Part two then of resource security is about water. So what we can see here is that the Earth's water is limited. We have a finite amount available to us. Only 3% is fresh water and less than 1% is accessible as surface water. About 30% locked up in the groundwater stores, and then a huge amount, over 70%, locked up in our ice resources. So areas that have low pressure systems are often water rich areas. So this is temperate areas, temperate climates, and tropical climates. Water scarce regions then are arid areas, hot arid and cold arid. So that is the polar regions and some of the deserts as well. We see increase of growth of the population, increase in urbanization, increase of demand of the growing population, agriculture using up a large percent of water use in order to feed that supply. So water and food production then are intrinsically linked. Water scarcity hotspots then would be in Middle East, North Africa, and Western USA, and creating a lot of tension between them. The area of virtual trade, then we can see water intensive products like cotton, beef, and coffee, means that their production is taking a lot of resources from one area instead of taking them from their own country. So USA exporting water via soybeans to China, for example, so that China don't have to use that. Transboundary water conflicts, then Nile River, we'll talk about that a little bit later. Mekong River that flows from China into Southeast Asian countries. So whatever is done upstream, this might create problems for countries that are downstream. Sources of water, then we get the water from surface runoff like rivers, lakes, reservoirs. We have groundwater stores like aquifers underground in the pores, and we have desalinated water. So this is taking seawater, processing it into fresh water by a reverse osmosis machine and then filtering it down and using it then. A very costly type of procedure, high energy needed to do this. So components of demand then 70, 20, 10, agriculture, industry, and domestic use. Now, if we look at the general drainage basin, this is quite important to understanding then why there might be shortages, where the water goes, how it flows through, and how our interaction with the drainage basin is going to impact the stores and flows. So the first idea then is that precipitation is the input into the system. That's where we're getting the water from. Otherwise, it follows gravity and flows out unless we trap it in places like reservoirs. But for now, we're just going to talk about a natural system and not include the kind of human element in it. So after input precipitation, we have an output out of the system, which is evapotranspiration. So going back to our unit on the water cycle, we go into this in quite a lot of detail. So I won't go through the whole process there. So evapotranspiration is the output. Now what we see then is as the rain is falling, it infiltrates into the ground, percolates into the groundwater store, and we see a water table. This water table then is distinctly telling us then which areas are saturated with water, and this is what helps create things like aquifers and areas that we can like drill down to and get access to that groundwater. So that's the concept there. That water table then can increase the more water is available there. We might see springs appearing, for example, as the water table changes too. So percolation, infiltration, very important. The porosity and permeability being important for that as well. Through flow to go through the soil, this direction, surface runoff to flow over the top down to the channel storage. Whatever is increasing surface runoff is going to increase the channel storage and the river discharge. So this is maybe causes of floods, let's say, for example. Now, in terms of resources, then we see that this could decrease the amount of water available. So if everything is going to flow off the surface and is going to leave the drainage basin faster through the river flow, this means then that we're going to lose that water and it won't be available for us and for vegetation. So maybe the concept of damming a river will prevent this from happening and will create things like reservoirs where we won't lose as much. However, the more channel storage we have or surface store that we have, the more evapotranspiration we can include there through evaporation. Interception storage then plays a critical role when we talk about vegetation and the availability of water. So sure, vegetation is going to take water up through the roots and it's going to utilize water, but it also causes interception, which allows for slower and more gradual infiltration to happen, and then followed by the second infiltrated water can come down into the soil and then get added to that soil store. So there you go. That's a way in which we can reduce the amount of water left, increase the water table, have groundwater recharge, and keep a consistency in the flow of the river. Remember, most ecosystems have the vegetation in that ecosystem, so it can control the water flow throughout. Porosity then, just as going recapping over this, so rapid flow through the soils then is going to have it has less pores, sand, but it's very permeable, so the water can go through, seep right through. Whereas clays, it can be hard to infiltrate into the surface, but it can then store a huge amount. And then sort of like a silt or loam then is going to be able to hold water, and that's going to be more favorable for some plants. So there's enough area for air to get through, water to infiltrate, and to also hold that water as well. Rock type then can create difficulties in areas where there's high permeability, like limestone pavement here. We can see that there's no vegetation and there's very little around the tops of these here. This leaves them as exposed rock because the water flows through so quickly that very little vegetation would be able to survive. So just in little pockets there where some sediment would accumulate and some nutrients might develop into a pocket, and therefore vegetation grows there. So as we said, increasing surface runoff is the key to if we're able to provide water for the area. The more that we have steep-sided valleys, the more difficult it gets. Impermeable rock creates then a hard surface with surface runoff. Having said that, while this increases surface runoff, the permeable rock, as I said before, might leave less water on the surface available for use of plants and humans. Thin soils can't hold that much, so the infiltration could be absolutely fine, but the saturation could happen very quickly. Urban areas then causes high surface runoff because of impermeable surfaces. Saturated soils means that no more water can infiltrate, maybe from like a previous day of rain, for example, or if it rains for many days in a row. It might not even be that intense, it just fills up the store and it's not able to percolate as fast as the infiltration rates are needed, so it exceeds the infiltration rates. High water table, as we looked at there, once the water table gets to a certain level, then we won't see as much percolation down below because it's occupied. And forested area then is controlling the amount of water reaching the surface and or going as surface runoff and reaching the channel store. So water stress then by definition is that demand exceeds supply and or when the quality is too poor to be used. So we can see physical water stress and economic water stress. Physical water stress is things like high pressure systems, where we see air moving downwards and we see less evaporation. There's less condensation. There is high evaporation, low condensation because the air is moving down. In order to condense, we would have a low pressure system where the air is moving up and condensing into clouds. So tropical rainforests have low pressure system, deserts have high pressure system where the air is moving down and there is no clouds. Economic water stress, that is poor infrastructure. This can be in places that already have a physical water stress, but they also have economic water stress, meaning that they have a lack of investments in proper irrigation management and water management as well. This means that their limited amount of precipitation can't be held and used correctly, or they might be overusing some resources like groundwater storage, for example. The relationship then with the physical geography, as we mentioned, high low pressure. So areas with high pressure then is in a low, or areas with high rainfall is in a low pressure area. Low rainfall scarcity is often in a high pressure area. Seasonal variability means that you have things like monsoons in Asia and dry summers then in the Mediterranean. So this creates high seasonal variability, which means everything has to be done with the seasonal precipitation. Geology, we already mentioned permeable, impermeable rocks, and the drainage basin. If it's a large drainage basin, it can supply more water than a small drainage basin, and also if it's small and seasonal, that's going to result in even harsher conditions. And if it's smaller, seasonal precipitation and low rainfall and impermeable surfaces, this is very bad indeed. So here's an example of how we have impacted and created water scarcity. The RLC from 1989 to 2008. It's not a very long time to have made such a dramatic change here, as we can see these changes from space. 90% of its original size lost. Now, this is almost all because of human mismanagement in an area that's already kind of physically on the edge. So Soviet irrigation plans was to take the water from this area and then make it into extensive cotton farmings in regions that would have flat lands between Kazakhstan, Uzbekistan, and Turkmenistan. This created like a channel of canals to move the water down into this area and use it for irrigation. So this would create cotton, and as we said before, this is the concept. The high It takes a high amount of water to use or to produce cotton, which makes it more valuable because other countries don't want to produce it then. We see the agricultural runoff, so irrigation projects for agriculture, use of fertilizer, pesticides. This creates then a bad water quality and degrades it to the point where it can't be used. The natural ecosystems then would die off, and this collapsed the local fishing industry as well. And we see the irrigation channels poorly built, so over reliance on then the groundwater table, and this reduced down the groundwater table until it was all used up. The water that remains then, high amounts of algae blooms. We have leaching of different nutrients into it and higher salinity in it as well, meaning that animals or fish populations have decreased there. The natural stress is very high seasonal variability between high and low pressure systems, so very little precipitation and a reduced amount of precipitation if we have a reduced amount of evaporation. So high amounts of vegetation and evaporation would go into the air, would cause then a cloud cover to form in the top of the troposphere and rain sort of locally in the area. So without that, then we're going to reduce the amount of precipitation potentially if we have less body of water. The arid climate then, just to be in a high pressure area inland away from the bigger oceans, means that it's limited in the amount of precipitation it gets. A couple of solutions to this problem though, looking at the changes. The Cock Dam then is to block it up and create more of a reservoir, so the RLC sort of becomes more of a reservoir than a natural body of water. Collaborate water management between the major countries that all share and rely on this agricultural production now. So those countries have to work together, and a lot of them are in conflict issues continuously. Water allocation then between the regions is very important, and how much is going to be in there, and basically the benefits of restoring the RLC to know, is it worth working together, and is everyone going to profit from it. So collaboration then is very important. Crop substitution then, taking away water intensive crops like cotton and changing the agricultural production altogether. Repairing and lining canals to make sure there's less leakages and evaporation. This means that the sides are improved, so less leakages back into the groundwater store, and that it's covered as well, so it reduces the evaporation overall. And then use drip irrigation. Good irrigation strategies can reduce water consumption in agriculture. It's very useful. So if we look at California with the water wars going on internally, this is then contained locally in one state, where we see a high amount of demand. So Mediterranean climate with hot summers and periodic droughts, high water demand, and the water supply then is variable. So we got farmers, residents, big cities, urban spaces, environmentalists, and the state government. So they all have to agree on how to use a limited amount of water. We can see that 80% of the water is used for agriculture, but it's only 2% of the GDP, bringing into question on what is the value in allowing them to hold on to most of the water. The inequality between north and south is obvious because the north gets a lot more precipitation, and this creates then an issue where they have to transfer large amounts of water, the state water project, and this causes then potential for a lack of water in areas where there should be more. So people feel that they live in the natural area and then it's artificially being taken from them in the north, whereas in the south they can see they're having the resources and a higher demand, so they request that it's brought down to the south. So that's a government initiative there. The drought then between 2012 and 2017 just showed the lack of water availability. Less snowmelt during this period put extra pressures on the region there, and farmers demand irrigation water. So this becomes then a big issue. Also, with the cost of farming then for almonds increased with high water use. So the type of agriculture then is questionable in the region if it doesn't match with the natural resources that's actually there. Wetland deconstruction then and reduces the biodiversity and the natural water table as well. So any factors of that can cause too much of the water to cause evaporation or to be used through agriculture then isn't following the natural kind of climate. Okay, so we see reduction in groundwater's level, over abstraction, financial loss for farmers, water restrictions on urban residents, and legal battles between all parties. Mandatory restrictions then were statewide from 2015. Desalination plants were opened, which require large amounts of energy, and groundwater management plan to reduce over abstraction because we know that this takes a long time to recharge. Water recycling programs then allowed for reusing of wastewater for irrigation. And we see this increasing or decreasing the demand, which is going to increase the supply available. A recharge of the water table is really useful and is a good aim to have. The long-term solutions of desalination, pretty expensive, and then environmentally is also going to be quite controversial as well to use that much energy to get a natural resource that you could get if you were using it sustainably. So national scale then we see in Australia, largest river system, four major states then joined up into one area and one of the biggest agricultural productions for the country. They see a high variability because of massive variations in precipitation levels and the changing currents like El Nino and things like that in the Pacific Ocean. We have the state governments then of these major states here: New South Wales, Victoria, South Australia, and Queensland. And yeah, looking for different water allocations and bigger demands. You've got the local farmers and indigenous communities who need different responsibilities and needs. The environmental groups then worried about the river health and the wetlands, of course, just to stabilize the natural systems and protect natural ecosystems too. So because of that, then they have stress from all sides, showing that at national scale, it can be very tough to keep an eye on all the water. On an international scale, then we can see the Nile River dispute, as mentioned earlier. 11 countries rely on the Nile overall, but Egypt and Sudan have the highest amount, completely reliant on it. The Grand Ethiopian Renaissance Dam then was built, and this threatens Egypt's water supply because it runs from there through Sudan into Egypt. Sudan then have the other kind of Nile tributary running through, and they join there and goes up into Egypt from there. Sudan's kind of caught in the middle because they're going to benefit from the electricity from the hydroelectric dam. Ethiopia, it's a major development project which gives them more stable energy supply, more self-reliance, and will help them in the goal for development as well. It also, for them, keeps the water in the region so they can use it, which is also good for development. So in that case, then, we can consider that Ethiopia sees it as more of an essential project, whereas Egypt then is heavily dependent on this water. For 95% of its water supply, it's an exogenous river then that starts in an area that has more precipitation and leads into an area that is more arid. So naturally speaking, Egypt then should have more desert, but it doesn't because of the Nile River. The Nile River Delta then is really important because this means that it can expand out these wetlands, which they produce most of their food on. So Egypt is heavily reliant on this river, and any interruption to that can have devastating consequences for this country. It's a classic case of international disputes, as the source of the river comes from one place and leads into one country and leads into another one. So Ethiopia is here, from the highlands all the way down there. We see the border into Sudan. It joins up, the Blue Nile joins up with the White Nile and becomes the Nile River, leads all the way down to Cairo, Alexandria, and that fertile area there, just leading into the Mediterranean Sea. So this has led to major threats of military action, reduced water for Ethiopian farmers, and a boost for Ethiopia in terms of electrical production and water supply as well, water guarantees. We can see that they're not directly border neighbors, and that brings Sudan into this area as well. The negotiations then have had to be between African Union and the United Nations, and pressure from the USA, World Bank to use this sustainably, sit down and make deals. There has been some deals struck as well, and then Egypt explores desalination, water conservation even more. They already have in Aswan, they have Lake Nasir and the Aswan Dam. But this creates its own challenges with rapid evaporation in the area and the levels going down. So if there's already lots of water trapped in other countries that's not getting there to fill their reservoir, this means then that this can negatively impact the rest of the country where most of the population is, downstream from Aswan. Now, in this area here, we can see the Iztapalapa. I hope I am pronouncing that right as always. But now it's a bit different because some of my students might be from there. And Mexico City there, we see overall has a water stress. So this is one of the boroughs there with 1.8 million people. And 70% of the residents have water shortages. So this is a major issue because it relies on then limited use, inconsistency with it. Now, this might be okay with certain elements of life because you can get things like bottled water, but it's harder with sanitation to have a regular supply to put it through the features for hot water. So any kind of like boiler system that they have really like is going to lead to better sanitation, right? So this is a big issue if it can't go through the main processes. So people would have to rely on other water sources. So water trucks even have to arrive to supply water to this region sometimes. Physical causes is because the Texcoco Lake, then in the major rivers nearby, been drained, and we see then tapping into aquifers underground have been depleted because of an over reliance for so many years and an inability to be able to provide different resources. Now, I'm not saying this is the case just here, it's the case in everywhere we've looked at so far, right? It's the case in the RLC, the case in California, even with now going on to thinking about Egypt and their over reliance on different resources. The over abstraction of groundwater has been universal around the area. The depletion of the groundwater resources and the reduction of the water table has happened all around the world to so many countries. And a lot of the time, this comes with major issues of environmental concerns being ignored, a lack of consistency in the government, and the inability for land users to look at the long picture. Instead, you look at the short picture, as we all tend to do, and look at the issues that are going on around us immediately and look how to deal with those problems. So, this has meant to continue use of a resource when we know it is not sustainable. So it's a critical factor most people can't overlook, and most governments are not willing to say no to the public because of the high demands. Like, even if we're just talking about the agricultural production in some of these areas, it doesn't make any sense to continue it. And it should be something that is stopped or changed in a very short period of time because of the greater, the longer we take to fix it, the longer it's going to take to be solved, right? So yeah, the abstraction can be far greater and much, much faster than the recharge levels can be. Okay, so we see seasonal and unpredictable rain, which is just climatic. That's what they're dealing with in that region. So more of a wet, dry season situation there. But those periods, the start of the wet season and the length of the wet season, then can change year to year. Over abstraction, then, as we mentioned there, poor infrastructure with pipes, cracks, and leaks, which leads to a lot of wastewater as well. So these leakages then cause major problems. And, when we looked at the case study of urbanization and issues in urbanization with London, that was one of the major things to solve there and in Mumbai was to fix old piping as well, so to make them more sustainable. The answer to progenic causes or human causes there, we have urban expansion and growth and urbanization, increase in the population, urban sprawl, the expansion of the city itself. Pipe water loss through leakages about 40%. Corruption and mismanagement continue to be a key factor in every single case study that we've talked about, and it happens here as well. Unequal water distribution, then areas then that would have better supply or preferential treatment, looking at more affluent areas, and water rationing in regions as well. So untreated sewage, then contamination in the groundwater store and issues with pipes regarding sewage can then lead to a degrading of the source itself. An illegal well starting to be produced would cause things like pollution of the source, but also abstraction in one area will take away from the groundwater table in another. So there might be decisions being made where they think that this has happened naturally, and this may affect then everybody's future development. So water harvesting is a good idea for almost all of these places for people to be able to catch the water off their roof or have a funnel or have different methods of catching water. In some deserts, they catch it in nets in the air and they let it condense onto the nets and then they drain those nets off. So there's definitely ways of having rainwater collection systems, and 30,000 are installed there. These are huge volumes of water that can last people many months after the water supply has gone down. It acts as a good emergency reservoir as well, and is just a good practice in general around the world, especially for people who have their own property or house and area to store it. This is a fantastic option because you just allow then more water to go back into the natural system, whereas you just take a lot of water that you need for personal use and you can potentially then clean it and filter it on site rather than it going through massive processes and the demands not being met by the rest of the urban area. Community water tanks then is long-term storage as well, an emergency water supply, and leak repair and pipe modernization is obviously one that can increase the amount by 40%, so should be done very, very quickly. On a national scale, then, it's the idea of water recycling, wastewater treatment as well, is becoming more popular in major urban spaces. So this is bringing huge amounts of wastewater into one area and then sending it back for use. As often in places, it's grey water that's used for things like vegetation. So rainwater harvesting, fixing leaks, water recycling, desalination, and expanding the pipeline. A lot of this just is very, very high cost, large infrastructural projects apart from the rainwater harvesting. So that's something that can be implemented very quickly and on a large scale. Okay, so that's water. That's why we're getting scarcities. It's always good to have multiple examples in your back pocket to use in different situations. Obviously, as well, a big factor there, like when we're talking about larger projects and different things like that, is the sheer scale of them and the cost of them. So changing all the pipes in Mexico City is just such a massive undertaking that it's not realistic in the time frame. With the Grand Ethiopian Renaissance Dam, it's such a major development, so it's not like that can be changed also. So you're also creating a system whereby you have a problem now and you have to find other ways around it. To remove the dam isn't going to be a problem now, or isn't going to be a possibility now for such a low middle income country. They have spent a lot and become heavily indebted to build that, so they're not going to change that on a whim or on the resort or on the demand of another country. So therefore, solutions around that problem have to be found outside of that. Whereas in other cases, we can see that the way that we use the water, like in California, having water intensive crops, like thinking about almonds, for example, it's too water intensive, and the same with the RLC as well. Growing cotton is too water intensive. So you need to just consider maybe changing that, and then the whole system then has less stress on it. So there are things that can be changed, and there are things where it takes maybe international agreements or local agreements, as we saw, like within a state between land users, that could drastically impact then the water that's available. And then simple technologies can be implemented on a small scale. So a lot of people are living in these conditions where there is a lot of easy, low technical solutions to these problems.